All right, so we talked a little bit yesterday about where the circumference formula came from, the 2 pi r. So if you have the whole circumference of a circle, it's 2 pi r, 2 pi being the whole circle, the angle that goes around a whole circle. Well, it turns out you can replace 2 pi with other angles in radian form to find out an arc length. So I want to explain what this is asking. It says find the length of each arc around your answers to the nearest tenth. So here's the angle, pi over 4, and the radius is 8 miles, and they want to know what this round distance is, that arc along the side. So basically what you do is the arc length is the angle, and we call that theta, times the radius. And theta must be radians, which is why radians exist, pretty much. So this is the formula. So it's the angle in radians times the radius. Okay, so if we have pi over 4 and 8, we're actually going to take pi over 4 times 8 on your calculator. You can just do pi divided by 4 times 8. And we're going to round it off to the nearest tenth because that's what it says in the directions. And it rounds to 6.3. Since the radius is measured in miles, that means this distance will also be miles. So this distance along the edge of the circle right here would be 6.3 miles. This would be a very big circle.
This is physics.
That's the worst thing I've ever
Yeah, actually you would use this in physics a little bit if you're talking about rotations. So
That's
yes.
stupid. I hate it.
Shh, we're recording.
Shoosh.
We are
I
recording.
didn't say it.
Okay, I now have something to bring to parent-teacher conferences next time. All right. So on the next one, we have a very big arc. It goes around the circle this far. The angle is 5 pi over 4, and they're giving us the radius is 2 pi. So you literally just take 5 pi divided by 4 times 2. Or you can do 2 times 5 pi divided by 4. Whatever order you want to type that in. It comes out 7.9 miles. Okay, so we made a table a little bit ago today that has some conversions between angles and between degrees and radians. So on this next one where it has 225 degrees, I need to have that in radians. You have to change it to radians first. So if you didn't have that table, you'd have to actually do 225 degrees over 1 times pi over 180 and simplify all of that, and it comes out to be 5 pi over 4. But since we made that table in our notebook, which I'll go back to show you, you could also look back here, and 225 degrees is pi over 4. We wrote that down. So that's why we did that, because this would be a handy table, so on today's lesson you would not have to do a conversion every time you see degrees. You could look it up. However, if this were like a standardized test and they gave this to you, you'd have to do it a little differently. So that's just my angle. And then I'm going to take that times my radius, which is 11, and round it to the nearest tenth, and it comes out 43.2 centimeters. So it's pretty simple on the problems up at the top where you just already have it in radians. You just multiply by the radius. Down here you would have to change the degrees to radians first because the formula requires radians. So what is 120 degrees in radians? Can somebody?
2 pi
2 pi over 3. So you guys already looked that up. So this is the same thing as 2 pi over 3. So now that I know that, I can just take 2 pi over 3 times 18. I had 180. And then we round it to 37.7. And since this is in meters, my answer will also be in meters. And so I guess I didn't highlight on the last couple. We're finding this length, this arc, for the angle that they're giving you for that central angle. We're just figuring out what the length of that arc is, which is useful in a lot of real-life situations. All right, so now we're going to switch and find the area of a sector. A sector I like to think of as a slice of pie, although this one is really big. So we're finding the area of everything inside here. So this is find the area. Actually, it says eind. It's supposed to say find. There's F's missing. Find the area of each sector around your answers to the nearest tenth. And so the formula for this, if you think about what area of a circle is, it's pi r squared. And since, I'm trying to think. All right.
It seems hard.
So since your radius and your pi, it's all, anyway, we're going to actually use, instead of pi, because pi is half of a circle, this is half of a circle, half of a whole circle to do the area of the whole circle. When we do our equation for area, sector area, we are going to take theta times r squared divided by 2, or sometimes they'll call it half theta r squared, and that's because they're only using half of the circle. It's how the formula works for a normal area of a circle, so we have to make sure that we're also doing half here. So there is a little dividing by 2. It's given in radians, though. You're basically going to have 3 pi divided by 2 times the radius, which is 11 squared, and you can get that answer and then just divide it by 2. And I think you could just actually just type all of that in. It'll be fine. And you get 142.5 square feet, because that's,
Inches.
oh, it is inches. Why did I write feet?
Because you wanted to.
I don't know, because I wasn't paying attention. All right, so 142.5 square inches. There we go. So there's an extra step. You got to divide by 2, but it's basically like pi r squared. It's just not pi because it's not a whole circle. This is how the kind of slice I like of pie. Since we have Thanksgiving coming up, this is like my slice of pie. That's your slice of pie. All right.
Gross.
I thought it was funny.
It
All right.
was good.
Okay, thank you. So over here we have pi over 2 is the angle. The radius is 14 inches. And so we're trying to find the area of this whole sector in here. I'm just coloring it to make sure you understand. We're finding that area. So we're going to take pi over 2 times 14 squared and then divide that answer by 2. So if you type all of that in and round it off, it comes out 153.9 inches squared. Is anybody having calculator issues, or you all understand how to type that in? Just pi divided by 2 times 14 squared and then divided by 2. Or you could do it in pieces if you wanted to, and just, it would be fine. Okay, so when we get down to the degrees, same thing as before, this has to be radians. So you want to convert to radians
3 pi.
first.
4.
And so Colton just looked this up. It is 3 pi over 4, and that's going to save us some time. If you happen to come across one that's not on the chart, you would have to do your conversions from degrees to radians first. But some of these are just common, so we can just use them. So we're going to have 3 pi over 4, times 11 squared, and then divided by 2. And it comes out 142.5, if we round to the nearest tenth, feet squared. And we found the area. That's the area of this whole slice. We call this a sector because it's a section. Has the same root word, probably Greek, maybe Latin, I don't know. But sector is basically a section of the circle. And then there is one more.
What was
Over.
the answer to number 6?
Number 6 was 153.9. So on number 8 down here, we're trying to find the area of this whole sector, this section of the circle. Did anybody look up 210 degrees?
7 pi over 6.
7 pi over 6. Good class. 7 pi over 6. If you didn't have a chart where you could look that up, you would have to do that conversion first. So we're going to take 7 pi divided by 6 times 16, which is the radius squared, and then divide that answer by 2, and we get 469.1 square feet.